My name is Becky Anashak. I am the federal point of contact for two programs that I'll be presenting today. I'll present each one in turn and take questions so people can leave after the first one if that's what they're here to hear. The first one is on the cybersecurity R&D program within the Cross-Cutting Technology Development Program. Lon Dawson of Sandia National Laboratories is the technical point of contact. I believe he's also here to answer questions if that comes up, so I will defer to him when we get there perhaps. I'll briefly go through an overview of what the program is, what our objectives are, and then get into the actual content of this year's call. The program is a cybersecurity program, but those of you who've been listening to many of these calls recognize that the Office of Nuclear Energy is not primarily a security-focused organization. So even though this program is security-oriented, our focus is the same mission as the rest of the Office of Nuclear Energy. We are looking to enable advanced nuclear technology development, improve cost effectiveness of current and future fleet, improve efficiency, support an integrated grid. There's all of these things that nuclear wants to do, and we're looking at how to make the cybersecurity aspects of that fit with the overall mission. A lot of our efforts are focused on improving cost and integrating R&D from other areas into the nuclear sector. We have four major R&D areas which will look familiar to any of you who work in cybersecurity: risk management, secure architectures, supply chain R&D, and modeling and simulation. However, each of these is designed to not duplicate what is going on in the rest of cybersecurity as a whole, or in the across industrial control systems or critical infrastructure sectors. This program is fairly small, and we're focused exclusively on unique aspects of cybersecurity in the context of nuclear power plants, specifically safety and security related controls and sensors, things that would fall inside the plant and generally inside the bounds of NRC regulation. For instance, risk management is one of our huge focus areas, and our effort is bridging the gap between the very different methods used by the cybersecurity industry generally and by nuclear power plants in establishing their safety basis. So when we look at risk management, we're trying to understand how would a cyber threat impact the otherwise understood design basis of a nuclear power plant. Can we integrate things like the probabilistic risk techniques, defense in depth, as used by the nuclear sector with those used in cybersecurity? So it's a very nuclear unique risk assessment approach, taking what's been learned by others and bringing it into the nuclear industry. Similar with secure architecture work, we're trying to focus on how you might do digital upgrades at existing plants or much more novel digital architectures for future plants that are very different from current ones. And what might the different features, design requirements, and operational standards be to take those concepts and use them in the context of nuclear power? Same thing with the supply chain and our modeling and simulation, which is where we have test platforms that we're setting up to be able to validate the research in the other areas. I'll very briefly touch on the interactions with other programs. If you've been in any of the other briefings on cross-cutting technology development or will be later, most of them have in common that the research is done on a topical area, but the implementation will generally, as the technology matures, be accomplished in conjunction with or even thoroughly managed by one of any other programs. For instance, if we're doing work on cybersecurity for existing plants, actually implementing it in the context of a digital upgrade might be managed by our light water reactor sustainability program. Similarly, if we design something to remotely or autonomously secure operations for a microreactor, the program that implements that would probably be our microreactors program. So we have close relationships with those other programs, and you may notice some seeming overlap among scopes, but we will work that out and make sure that everything is clear as needed if questions come up. The interests of the call this year are fairly different than what we've had in previous years. In the past, the program was fairly young, and we were interested in a broad range of ideas covering all of the scope areas of the program. This year, we'd like to focus more closely to help the calls coming through the university awards mirror the most pressing needs of the program. So we are focusing in on secure communications for future reactor technologies primarily. And again, we are looking at safety and security related sensors and controls and how to secure them. Of most interest are cybersecurity concepts, architectures, and technologies that can enable the novel architectures and use cases of some advanced reactors. For instance, the most compelling proposals we would see would be those that can help secure the control and monitoring systems for remote operations and support expanded use of data for operational decision making. The distinction between those two bullets is primarily actual reactor control type security or some of the ancillary things that are needed to help with maintenance and other operational things that still require cybersecurity, and figuring out how to accomplish those specifically within nuclear reactors and in the context of the regulatory frameworks that these are operated in. Things that are not of interest, even though they may be important, are general purpose attack scenario modeling and intrusion detection tools for plant operations. We have awarded some in that area in the past, and we're looking to move in a different direction and start getting some ideas in some different parts of the program this year. We are also not interested in technologies, tools, and methods that are just broadly applicable to industrial control systems, unless there's something very unique about adapting those techniques to the regulatory and operational context of a nuclear power plant. And for those, there would have to be specific information about what it is that needs to change and why to make it work in a nuclear power plant. So we would not be interested in just taking something that exists and saying, let's try it in nuclear, if there's not a clear understanding of some adaptation or novelty that exists about nuclear as different from other industrial control systems. I also have some information about previous awards that have been made under this program. Those are just for general reference because proposers should be aware of what kind of work we have already done in the past, and note that we're trying to move forward and not repeat any of this. We want new ideas that enable new kinds of technologies. Again, architectures, technologies, and a specific emphasis on remote and autonomous operation and wireless is most of interest. That's all I brought on that topic. If we want to take questions in this area before moving to the next one.
Yes, we will. For those tuning in for the cybersecurity session, please enter your questions on the question and answer box on GoToWebinar. We will take a minute or two break here just to collect questions. And if we don't get any, we'll just move on to the CT-2, the integrated energy system scope. Becky, our first question. Is the focus more on an entire control architecture or more on the secure communication methods?
Specifically on the security aspects of it, we would not be looking at an entire control architecture. I think for that, there are probably some other elements of the call that might be of more interest for whatever specific reactor technology is being controlled and so forth. But if you're looking at the security architecture of that control system, that is of interest. Was that a clear answer?
We'll welcome a clarification question if needed. A second question, is supply chain security considered out of scope for this year? You highlighted wireless communications more.
It is not out of scope, but what's most of interest is the wireless and remote operations. The only things completely out of scope are the things we mentioned as not being of interest. So if it fits within the general description of what we provided in the call, then it's in scope.
What is the difference of focus between the NEAT Crosscut 2 area wireless technology for nuclear instrumentation and control systems and CT-1 cross-cutting research cybersecurity research?
I'll try to not speak too out of turn on the nature of the other call, but the other one is focused on the actual sensor technologies. And this call is focused on securing the communication, so specific elements of cybersecurity protection.
Okay, let's move on to the second presentation, and we'll take any questions on both presentations after that presentation concludes.
Okay, thank you. And I will note for any cybersecurity interested researchers stepping off, there is a cybersecurity element of this one as well, although it's fairly small. The next topic is integrated energy systems design and modeling. Again, I am the federal point of contact. The technical point of contact is Shannon Bragg-Sitton of the Idaho National Laboratory, who's the national technical director for this work. The focus of this program, I'll try not to read everything to you, but the mission statement really is important, is we're maximizing energy utilization, generator profitability, and grid reliability and resilience. We do that through systems integration and process design using nuclear energy across all sectors in coordination with other generators on the grid. The basic translation of that is hybrid or integrated energy concepts that make the most efficient use of the electric and the thermal energy coming from a nuclear plant. The idea behind this is to allow nuclear power plants to be available to support a resilient grid and a baseload capacity, but operate flexibly as renewables and other types of technologies come on and off the grid. Right now, that flexibility and demand is posing significant economic challenges to the nuclear sector. And it also causes inefficient use of the energy resource that's available in a steadily operating nuclear plant. So the Integrated Energy Systems, or IES program, is developing the tools and the technologies focused on commercial demonstration of these integrated energy systems. It's a fairly urgent need. The timelines for the work that we're doing is really driven by the availability of the different reactor concepts coming to the grid. Our goal is to have R&D in place so that as these different types of reactors come online, they ideally would be able to come online in conjunction with integrated energy systems so that they can bring the most value for these new investments coming aboard. The work from this program has already been transitioned to the Light Water Reactor Sustainability Program, which is funding pilot projects at existing nuclear reactors for hydrogen production. And we expect similar transfer of the work that we do into small modular reactors and non-light water reactor concepts as those come online. Our major R&D areas are system simulation and experimental evaluation. The system simulation area is focused on having a very flexible plug-and-play ecosystem where we can bring in models of different components and examine their system performance in the context of different demand scenarios for the electric and the non-electric applications. We've recently brought in a new area to that, which is economic analysis. It's not specifically related to integrated systems, but it's an input that's needed for being able to properly value integrated systems. So that's why it's here. But looking at how nuclear energy is valued in the electric and non-electric marketplaces and studying those economics. And that's a subset of our simulation area. Experimental, we have a capability at the Idaho National Laboratory, and we work in partnerships with other national laboratories to perform high fidelity simulations of various system elements working in concert to understand the system effects of different types of energy storage, end use applications, and nuclear and non-nuclear generation technologies in an energy system. The scopes of interest for this year are primarily focused on non-light water reactor technologies in integrated systems, on advanced performance optimization techniques, and on IES cybersecurity. That's 3 different sub areas, and I'll go through each separately. For advanced reactor or non-light water reactor areas of interest, we are interested in feasibility studies, concept development, and optimization of systems that take advantage of some of the unique characteristics of these advanced non-light water reactors. In general, different temperatures come to mind, but they have a variety of novel features that could be considered. We're looking at process design for nuclear system integration specifically. For instance, how do you modify different processes to make them work together in an optimized energy system with nuclear? And we are looking at interface designs such as advanced heat exchangers, intermediate loops, balance of plant changes and control systems to help have an optimized coupled process. Areas not of interest in this sub-element include novel reactor designs. That is really not what this program does. And we also, it's been a little bit unclear. I want to make sure this comes through more clearly in this year's call. This program generally does not support development of the end-use technologies, except as they need to be modified to enable or enhance their use in a nuclear integrated energy system. And I put a couple of examples. These are not exclusive by any means. But for example of what we mean, if you have a novel method to improve the efficiency of something like a hydrogen production method, desalination method, some other industrial process that could be used with nuclear, but your proposal is strictly focused on an improved, more efficient way to do that end-use technology, that is generally not of interest. On the other hand, if there is an end-use technology that's already out there, but it could be made better by integrating it with nuclear if only we change some process parameter. Again, temperature comes to mind, but it's not the only one. That would be of interest. But to really make that clear in a proposal, we would expect to see an explanation of what the parameters need to change, how those are well matched to some particular integrated energy system concept, and why bringing it into that integrated energy systems construct is a valuable improvement over the current state of the art, either for the environmental, economic, or other benefits. So basically, why would you put it with nuclear and what needs to change to make that happen? And in that case, some process development is of interest. In the performance optimization area, we are interested in algorithms for the real-time optimization of dispatch to maximize the economic performance, and an emphasis on working those systems with nuclear power plants, either current or future. And we're looking at real-time updates of control system predictive capabilities and large-scale data assimilation. The specific area not of interest here, and again, I have a with an exception kind of a thing, so I put some examples. We're not generally interested in demand forecasting tools for the electric grid or for the associated non-electric processes that might be used in an IES, except as part of a feasibility or optimization study. So for instance, we are not interested in primary proposal subjects that would be electric grid demand models or forecasting tools. There are other parts of the Department of Energy that really focus on that work. So that's not this program's emphasis. On the other hand, if an IES feasibility or optimization study is proposed and the existing models are not available or not compatible with the concept and methods, then those kinds of forecasting tools might be appropriate to include in a proposal. In the cybersecurity area, we are interested in starting to look at how you perform cyber-informed engineering so that those considerations can be brought in the early stages of designing the architectures for integrated energy systems. So cyber-informed engineering approaches, architectures, design concepts, cost-effective approaches to cybersecurity while you have different energy systems with data exchange, control interactions, with the multiple producers and users working together. The cybersecurity architectures could be very interesting and should be thought about in these early stages. And also concepts for ensuring and implementing cybersecurity in the context of multiple regulatory safety and security frameworks, depending on how these systems are implemented. So not of interest are general industrial cybersecurity techniques that don't address specific challenges to integrated energy systems. So for instance, we are not looking for technologies to detect, prevent, or respond to ICS cyber intrusion. but we would be interested in cyber-informed engineering approaches that maybe bring together requirements and techniques of the nuclear sector and some other participant sector within the IES. We would also be interested in security architectures and technologies that segment the nuclear and non-nuclear subsystems to simplify the design, licensing, and management. A few other things to consider. Even if a proposal is not cybersecurity specific, if it is looking at areas where it's systems design, dispatch optimization, and things, cyber-informed engineering should probably be a consideration to the extent that it's relevant. Any computational models being developed, we do prefer them if they're capable to integrate with the Medelica and Raven-based ecosystem that we've been building out at the national laboratories. Systems of interest could be applicable to fixed installations or could be modular and transportable. Although for the latter, I would also encourage people to take a look at the other element of this call in microreactors because they have some content relevant to integrated energy systems. And then principal investigators are encouraged to investigate the markets and the market competitiveness of the proposed solutions, either within large-scale centralized grid or islanded microgrids. So there's different applications possible. And that is all I have if we have questions.
Thanks, Becky. We do have one question in the queue. Is hydrogen production a preferred end application for IES?
Not necessarily. It's one of many that could be considered. We have done work on hydrogen, but we're open to other concepts as well.
That's our only current question. Please submit any other questions. We'll keep Becky here for a minute or two longer. So please submit them now if you have them. While we're waiting, I will unmute Shannon. Shannon, you're muted on your side. So are you there?
Yes, I am.
Okay, we can hear you. Next question. Is integrating heat storage to high temperature advanced systems of interest?
Yes.
Is experimental validation work of interest?
That's a fairly broad question. It's hard to say. If it's experimental validation of the kinds of concepts that I discussed in the presentation, I believe so. Shannon, did you want to elaborate on that at all? It's kind of hard because I know you have to be vague during proposal discussions. But...
In general, you're right. It's a very broad question, and I would say yes as well. If a model is developed for, I'm going to use the previous question as an example. If there's a model developed for integration of an advanced system with heat storage, and you have a facility that could be utilized to validate some of that model, that's great. I think that's very good. You know, an outcome from a proposal that is a validated, experimentally validated model of some aspect of an integrated system that falls within the interest areas, I think that would be very much of interest.
Is the Medelica-based IES software available for inspection by faculty and students?
Shannon, I'll defer to you again on that one.
Okay. So yes, there's quite a bit that has been put together with regard to the modeling and simulation tool set. Much of that actually has been recently moved to open source. If there are specific questions with regard to how to access that, how to assess what has already been developed with regard to component models, we can certainly provide a broad summary of that and provide that information, you know, fully to the community that's applying to the CINRs. It's fairly comprehensive, and as I said, you know, some of those tools just were authorized to go open source as recently as last week. So absolutely, some of those are out there, and we can certainly answer some of the more detailed questions and provide information broadly.
Will developing small-scale IES at universities be of interest?
Small scale IES in universities. I'm not sure I followed the question.
So let me try to
go ahead, Shannon.
expound on what I think the question is asking. So many universities have self-contained power systems, you know, something that is operating on campus to provide power and heating on campus. Modifications of that, evaluation of that relative to the scope within the IES program here and how it relates to nuclear systems. I think that could be very applicable. You know, I'll use an example of, you know, if you had a really small scale nuclear system that could power a campus, that would be a really interesting topic to consider, and that could be cross-cutting between the microreactor program and the IES program. But we'd have to understand a little bit more detail.
Yeah, if that's the kind of thing what the question referred to, I would agree that there is potential interest there.
Is control system design and optimization for IES integration of interest?
Yes.
And again, on that question, I would recommend that, and perhaps I'll talk to our modeling and simulation lead about putting out some very general information. You know, here's where you can go find details on what we've already done in control systems that could be built upon. So we have done some of that work, but it's absolutely not complete. And so I want to make sure that proposals build upon the tools and capabilities existing and don't go off, you know, in left field developing something new, because we want those to integrate with the other tool sets.
Is the efficient management approach besides integration of interest?
If we're talking about, for instance, I guess it depends on if management approach is really like administrative or technical. If efficient management approach would be things like machine learning and variable demand forecasting for dispatching and so forth, yes. If we're talking more about administrative management, then probably not.
Okay. It looks like, oh, hang on. We do have one more question that just came in, and then I think this will be our last question. Is there any specific small modular reactor or microreactor preferred for integration?
No, definitely not. We are open to all concepts that are out there in terms of, I mean, obviously a focus on reactors that are realistically out there under development, not a novel new idea, but otherwise it's fair game. We hope that all of the different reactors potentially coming to market have options to work in the integrated energy systems context.
Okay, thanks, Becky. Thanks, Shannon. Those look to be all the questions. We will return in about 30 minutes at 2 o'clock Eastern for the TCR work scope. So please tune in then. Thanks.
Thank you.